Okay, this is an unboxing video for the ADRV9002 eval board. It's connected up here to the Zinc 3 board from Analog Devices, but the ZC706 board from Xilinx would be the same. So you get the board and you plug it into that FMC slot closest to the SD card. There's two SD cards that ship with this board. You use the one entitled TES. And I want you to notice the LED lighting sequence as I power this on, and it will show what a successful boot looks like. When the board powers on, you can see in the lower left-hand corner there the kind of the Knight Rider sequence of the LEDs flashing back and forth. You can also notice on the eval board that there's a green and a red LED on. That red LED will turn off after startup, leaving just the green LED on. That green LED is like a system OK for the FMC eval board. And then after the FPGA has finished its boot successfully, then those LEDs that were flashing back and forth, those will all turn off. And just that row of other LEDs, a little hard to see because they're all because they're too bright. Those LEDs will turn on. Will stay on. So now let's talk to the board here. And to do that, we can use PuTTY. So this PuTTY is just connected into the UART through a USB cable. A couple of returns brings up the prompt. I'm using the DHCP method to communicate with the board. The other method is the static IP method, and this is talked about in the eval board guide. I have better success with the DHCP method. I'll post a link on this video how you can connect via either method. But if using the DHCP method, you just enter in this command, dhclient space ETH0 space -v. And that will respond with some IP address. It'll be different for you, but for me, it's 192.168.0.3. And then I use that in TES. So TES is launching now. And I put that IP address in here. 0.3 and hit connect. And you can see that it identified the 9002 board and the variant of the 9002 board that I have, which is the 30 megahertz to 3 gigahertz version of it. And so this is all connected. Now I'm going to hit program here in a minute, but before I hit program, I want to make sure that everything is configured properly. So we just step through these pages over here on the left for the configuration. The device configuration, I want FDD since I'm doing a loop back from TX to RX. And I want something with a little more bandwidth so we can see some more signals. I'll choose an LTE profile with a higher data rate. We're not going to change anything else on these tabs, but I'll cycle through them just so you can see what they look like. On this tab is where we configure all of our clocks. We could also switch to a lower power receiver to save some power dissipation. And we can switch to a lower power clock too to save power dissipation. Filters, we'll leave those. And this is what the receive filter looks like. And the transmit filter. Okay, so everything there is as we want it, and we hit the program button. And in the lower right-hand corner, it will say programming, and then when programming is successful, it will let us know that. Okay, so it is all programmed now, and now we can start using these tabs up here at the top. Before I do that, though, I want to open up a couple more interesting things. If you go to View, you can view the radio state. This has the different statuses of the receivers and transmitters. You can see they go from reset to calibrated to prime to RF enabled. And you can either set these here or you'll see these update as we do different interactions with the GUI. We started in the reset state before I hit the program button, and now it's in a calibrated state. So that's one interesting thing to view. And then the other is this interesting thing is this power monitoring window. This allows us to keep track of the instantaneous current draw from all the supply rails. And this is interesting because we looked at a couple of things that we could click to enter into lower power dissipation modes. And so you can kind of track that. As things start to turn on, you can track the power dissipation from each of these rails real time. So we programmed our board. We got these panels all set up, and just note kind of how they change. The radio states change as we enable different things, and the power dissipation changes as we enable different things. So we go to the transmit tab, and you notice when I click transmit, it automatically went to the primed state. On the transmit tab, I can now output single tone, two tones, or some IQ data file. So we can do a two tone here. Here's a 3. Let's do 3 and 5 megahertz. And we can play that, see what that looks like. Adjust the attenuation. I also have a 10 dB attenuator in line with my SMA cable, just as extra insurance. That's that. And then on the receive side, and you can see when I hit receive, it went to the prime state there. We can do a capture, and we're just looking at channel 1. And we can adjust the gain on the receive side. And you can note the total power dissipation now from each of the rails, and all of our transmitters and all of our receivers are enabled now. Here you can manually adjust the gain by using the RX gain index. The gain index is the gain table, which is configured for this setup in 0.5 dB steps, but you could change that by changing the gain table. But we can also go to automatic gain control. And now if we come back to receive, the RX gain index is now grayed out. It's automatically adjusting the RX gain based on an AGC loop that we can program in the gain control box. There's some other interesting tabs here. I'll just show them to you briefly, but we're not going to discuss them, but just so you kind of get an idea of what's there. The receive side, automatic gain control tabs. There's quite a few settings here that you could set on the receive side. Transmitter attenuation control. Some interesting new power savings and monitor modes. TDD modes and options. Tracking CALs that I suppose you could disable if you wanted to, but best just to leave these alone. And then digital predistortion algorithms, and finally some auxiliary functions that you could enable or use. Okay, that's about it. So let's shut things down here. And to shut things down safely, we want to shut down the FPGA first. So shut down platform. And when we do that, you can see the FPGA log of what's going on there. Does all those things here. Then we can quit TES. And finally, we can turn off our FPGA board. And that's it.